Thanks for joining us today. Today we're going to be introducing the ACCQPrep SFC and Preparative Supercritical Fluid Chromatography made easy. And today I'm joined by Todd Anderson again, our global chromatography specialist. And Todd has a diverse background in both preparative and chiral purifications, and he's here to share his knowledge with us today as we discuss the ACCQPrep SFC. So the outline today is we're going to review our webinar from a couple weeks ago and the benefits to SFC and obstacles to its broadened use. And then we're going to introduce the ACCQPrep SFC and take a tour of the features and benefits of the ACCQPrep SFC. And then we're going to highlight some workflows with the ACCQPrep SFC with both chiral separations and then achiral open access using the ACCQPrep SFC auto sampler options. So to review from our last webinar, we discussed the benefits of Preparative SFC. And one of the main benefits is that it offers us comprehensive chromatography. We can do chiral or achiral purifications. It's an orthogonal technique to reverse phase at HPLC. And it offers alternative selectivity from many stationary phase options, and it offers us a wide solvent polarity range. It also offers higher efficiency. It increases our throughput. We can run 3 to 4 times faster than Prep HPLC. And the great thing about supercritical CO2 is it's easily eliminated at the end of the run. This results in faster processing time as we reduce the amount of solvent that we've used, and we have more concentrated fractions. And also there's no water to remove as we see in reverse phase separations. One of the additional benefits is it's a move towards going green, and it greatly reduces our solvent consumption. And it also reduces the amount of solvent waste we generate, which requires energy to remove the solvent and then also to process it and dispose of it. Supercritical SFC is a CO2 neutral technique. We reuse CO2 generated and captured from other processes or the atmosphere. And then finally, it offers some safety enhancements. So we're able to use environmentally friendly alternatives to hazardous organic solvents. And it's also non-toxic, and we can use this with the appropriate co-solvents for safe use with food and pharmaceutical products. And there's a quick review of some of the discussion we had last week regarding the historical limitations of Prep SFC. Typically, a lot of the Prep SFC systems have really large system footprints, so it requires a significant investment in space from a lab to be able to use these systems. There's been a lack of versatility in the systems. They've been kind of focused on being able to purely do stacked injections, and it limits some of the applications that we can apply Preparative SFC to. Keeping CO2 supercritical introduces some more complicated components to the system. And because of this complexity, it leads to the complicated systems and difficult to run and requiring expert users to do it. Additionally, there's a need for CO2 supply infrastructure. So you may need to have a bulk CO2 supply source or multiple high pressure CO2 cylinders that you need to be aware of to provide the CO2 for your system. And typically there's kind of burdensome software interfaces that aren't easy to use and not friendly to users who aren't experts in the field. And we've been limited until recent history with poor sample recovery options. You haven't been able to do open bed fraction collection easily, or there's limitations to your methods, or limitations to the flow rates, or limitations to the solvents that you've used, or maybe you get poor sample recovery from those runs. Another concern is the system reliability and service requirements. Because it's such a complex system, you do need kind of dedicated service, service personnel, trained service personnel for these systems. And decreasing the downtime that you need will increase the amount of throughput you have in your lab because your system's up and running. And then finally, expert users only. So Prep SFC hasn't been really brought into mainstream labs. You're going to your core groups for this, where you have experts doing Prep SFC every day. And that's been a limitation on some of the Prep SFC advancements because we're not using that on a daily basis in other labs. And it's unfamiliar to people. Okay, at this point, we'd like to introduce the ACCUPrep SFC. You'll see the ACCUPrep SFC here paired with our auto sampler with open bed fraction collection test tubes, our patented GLS, and then the base system, which you can use by itself with just this fractionation valve. And we'll go into the highlights of some of this as we progress. So some of the key points we really want to highlight with the system is that it's a really versatile system. We can do chiral or achiral separations in a single compact solution. So it's a single system that can fit your spacing needs. You can use just the base system that you see on the bottom left there and collect into bottles with the standard fractionation valve and do automated sample injection of a single sample with the standard auto injector. And it really occupies a small footprint in the lab. It's not much, it's the same footprint as our Prep SFC or our Preparative HPLC system. And you could easily fit multiple systems of these inside the hood. You could expand the versatility of the system by adding an auto sampler, simply adding an auto sampler to the mix. And there's two different options there that offer two different sizes depending on what your footprint allows and what your needs are. So you can do more with less bench space and easily switch between workflows with ease. Additionally, the ACCUPrep SFC is it's built with a robust CO2 pumping system that has that's paired with advanced mass flow controller and automated back pressure regulator to ensure accurate flow control. We can go up to 200 milliliters per minute combined system flow. And we can also run from 5 to 70% co-solvent. It comes standard with a 4-solvent selection valve for the co-solvents. And it's designed to optimally run columns up to 3 centimeters in diameter. Additionally, the high pump and system pressure limits enable the use of smaller particle columns, as we're seeing a trend towards higher resolution purifications by using smaller particle size, which generates higher back pressure, and you need a more robust system to be able to tolerate that. Additionally, ACCUPrep SFC is powered by our intuitive peak track software. This is at the core of the system, and it combines ease of use with powerful control for ready-to-use experience for any chemist. We can increase our throughput options and efficiency in the lab because we can allow unattended operation to process sample batches, single sample batches, or multi-sample queues for open access labs. And then finally, probably one of the really nice things about the system is that stable chromatography standard. So it's loaded with standard features in order to offer consistent, reproducible, and easy to perform chromatography every time. So that means it's standard with a column oven drawer that's thermostated, standard with a 6-column selection valve to allow you to switch between different stationary phases you may be using, 4 co-solvent selection valve allowing you to blend different solvents or change your modifiers without having to change bottles. Standard with an 8-port fractionation valve to allow you to collect into any user-defined bottles of any size. And so you can use that for your stacked injection workflows and use the system without an auto sampler. Comes standard with a PDA detector, standard with a makeup pump to ensure that you have appropriate solvent sample recovery at low flow rates and low % Bs. Standard with an auto injector to allow you automated injection, whether that be stacked injections, a single sample, multiple runs of a single sample, or even combining that with our auto sampler to do multi-sample operation. And then finally, standard with free software updates. So you're always going to be taken care of when the system's improvements are made to the system and we release new features and things like that. So what about the size? And so one of the great things about the ACCUPrep SFC is that you can do more in less space. So if I have a dedicated stacked injection system, you can see the ACCUPrep SFC there on the left. And the 3 boxes on the right are different competitor systems footprints. And you can see that you could probably get 2 to 4 ACCUPrep SFCs in the same footprint as some of these other stacked injection systems, and you don't need a PC. It's the smallest Prep SFC on the market, up to 200 mils per minute. It's an ultra compact solution for single sample batch purification. You can do automated stacked injections. You can do automated single sample batch gradient purifications. You can collect up to eight fractions, and you can do fraction pooling into those containers. Increase your throughput. You can fit multiple systems in that same footprint, and it easily fits inside a hood. Like I said, no PC required. As an integrated 15-inch high-resolution touchscreen interface. This frees up valuable lab bench space. And you don't have to worry about compatibility issues when the operating system upgrades every few years. And free system updates for life. If you pair the ACCUPrep SFC with an auto sampler, you have 2 different options. So depending on your footprint, if you have limited space, but you need the auto sampler capability, we offer the SFC auto sampler 2x2. This is a versatile compact solution for single sample batch purification and multi-sample open bed fraction collection. So we can switch them back and forth between the 2 workflows. This enables us to do automated stacked injections. You can do automated multi-sample purifications, and you can use the open bed fraction collector or use the standard 8-port collection valve. The open bed fraction collection allows 2 fraction rack positions. You can collect up into 150 16-millimeter test tubes, or you can even do open bed collection into bottles. Once again, no PCs needed, so freeing up valuable lab space. And then finally, if you have need more sample capacity to get more done, we do offer a larger auto sampler, SFC auto sampler 4x2. This offers expanded fraction collection capacity for open access and high throughput labs where you have multiple samples coming through from different users. Once again, all the same benefits as the 2x2, just an expanded bed. And once again, no PC needed, free up your bench space. So we discussed earlier the pumps behind the system and how you can go up to 200 mils a minute. But why does it matter that we can go up to 70% co-solvent? And one of the things that SFC is starting to explore more is the polarity limits of it. So as we increase the percent co-solvent, we get up into that 60-70% range. We can expand the polarity range of the compounds that we're purifying. We touched on this last week in regards to expanding achiral use, expanded achiral use into preparative SFC. And having a system that's able to perform up to 70% co-solvent composition at the maximum flow rate means that we can expand the range of compounds that we can purify into some of these more polar molecules. The other great thing is that there's no GLS flow rate limitations on our system at these higher co-solvent flow rates, and that extends to our system capabilities. So we discussed how stable chromatography standard. You can see there the oven drawer. It's a thermostated oven drawer with capacity for up to 6 columns. Designed for 3-centimeter column diameter, up to 250 millimeters in length. Easily switch between the 6 different columns. The variable temperature control allows you to go from 5 degrees above ambient to 70 degrees Celsius in order to ensure consistent chromatography for long runs. The ability to have the space for 6 columns is important in SFC because, as you can see, as we discussed last time, there's so many different stationary phases in both chiral and achiral purification that are used in SFC, since there's not really a universal C18 yet for SFC. And so having that space to easily switch between columns without having to disconnect and depressurize your column helps save you guys time when you're doing your separations and switching between columns. Additional thing that contributes to stable chromatography is we want to keep our pumps running during runs. We want to be able to know if we're going to have any issues that might stop operation. One of the unique features that Teledyne ISCO has offered on our preparative HPLC and our flash systems is active solvent and waste level sensing. And so one of the great things about this for SFC is that you can have predictive solvent notifications to say, you're about to run out of solvent before your pumps stop. And then you need to restart your purification. So you can refill during your purification and keep the pumps running and keep your stacked injection or your multi-sample queue up and going. The other thing at the core of the system here is our integrated patented gas liquid separator. So you can see in the video here, you can see the flow down the sides of the GLS there, some different angles. You can see the liquid flowing down to the bottom, and gas expansion is being released to the port there at the top. And what this does is it removes the CO2 as it comes down to atmospheric pressure after the back pressure regulator. And so this is a unique patented design. And the great thing about this is it facilitates both bulk collection using the fractionation valve and also open bed fraction collection. So we can do either option without compromise. You can access the full capability of the system. This GLS isn't limited to limited by flow rate or liquid flow rate. So we can operate up to 70% co-solvent without any flooding or anything like that. There's an automated makeup pump to ensure that high sample recovery at low flow rates and low co-solvent compositions, and it'll offer 95+% sample recovery. This is a low maintenance design. It's almost self-washing as the liquid comes down the sides there, and it minimizes the downtime with its reliable and robust design. So at this point in the presentation, I'm going to kick it over to my colleague Todd, and he's going to discuss the different workflows with the ACCQPrep SFC.
Thanks, Josh. Great presentation so far. I really appreciate working with you. We're going to go ahead and continue with some chiral separations with the ACCQPrep SFC. Josh was kind enough to go over a bunch of the achiral stuff, and now it's my turn to go over a little bit of how I see us doing chiral separations with the system. So as you can see, there's two different prep workflows traditional on SFC workstations. Typically, you're going to have a bottle collection, as you can see here on the left side. And then you also have a auto sampler type collection where you have some sort of GLS, which Josh has already kindly gone through. So as we look through that, we can actually see the bulk purification on the left-hand side is going to be mostly for stacked injections. We use an 8-port fractionation valve, and we can pull the fractions from any of the valves or just multiple injections. We can pull into 3-4 vessels and just keep on repeating. If you had 2 different samples, you could even keep 2 sets of 4 traditional for collection. We can also run automated multiple injections with that. You can kind of see a little brownish bottle right there next to the left of the collection vessels. That's actually where we would be drawing in our sample for repetitive injections. This is usually where we would wind up using the stacked injections for this type of setup. The other option is multi-sample purification. Most of the time, you're going to see this with achiral purifications, but there are circumstances where maybe you might want to do multiple compounds of the same classification or on the same column, and you just basically want to run multiple samples. We can actually do that with the auto sampler and collect into different tubes so that you get a set of tubes for each individual fraction setup. So we can do unknown or uncharacterized compounds if you want to do that as well, which is becoming more and more of a trend. More likely, eventually we will be coupling this with mass spec. So that'll also help for the fractionation so that we can actually minimize the numbers of tubes we actually collect per run. So we can actually run an entire rack of samples and not run out of space on the collection bed. We'll get into the differences between gradient and isocratic that we'll need for stacked injections. But this could also be used for gradient elution, as Josh was going through in his portion, where we would have multiple types of columns and do different types of column chemistries. We could do that with multiple different types of columns. Next, we're going to take a look at what stacked injections are. So I mentioned them previously in our last webinar. As Josh mentioned, we're going to try and revisit some of the stuff that we've mentioned before, but try and expand on it a little bit. So for stacked injections, there's going to be 4 requirements that we typically look for. And that's going to be that the samples have minimal to no impurities, because you don't want to have stray compound landing on top of one of your isolated peaks. So we need to make sure that you have a pure sample coming in, that the separation is isocratic. And as you can see by the blue line, we're running at about 20% co-solvent in this particular run. They have to have closely near full resolution. We can get partial resolution and take the interstitial space and collect that into a middle fraction, if you will, almost like we have on the tube 2 right here. But it's better if you do get full resolution so that you can actually have pure compounds, and it'll help the software to calculate these, as you'll see in a second. And then finally, you need thermal stability. If you don't have thermal stability, the peak retentions will be shifting and drifting as time goes along. So we want to make sure that we have a very smooth and unaltered stack of injections so that we don't have any drifting and potential loss of sample or co-mixing of sample. The system will still collect them and separate them, but your peaks might shift a little bit and you might overlap one another. So how do we determine the stack protocol? Well, traditionally, you're going to use a overall runtime. We're going to use a cycle time. And then the cycle time is just basically the point from the first point of which we want to collect to the very end of the last component that we want to collect. It could be one compound, it could be multiple compounds. In this particular instance, we do have 3 compounds. 2 are enantiomers, and then 1 is a interstitial impurity. So we're going to try and pull that impurity out and still get pure peaks 1 and 2. Or we can let PeakTrack do it for you. So if I step onto the next slide, here's a graphical representation, actually a real live slide that Josh pulled over for me from the ACCUPrep SFC. As you can see, we have 3 tubes on the left-hand side where we're displaying the individual fractions. So we know that this is getting collected into the open bed fraction collector. And we want to run a test isocratic method run to establish our baseline for the separation. As you can see, I sort of glossed over it, but down to the lower right, you'll see that it is a quick button that just says stack injections. So when we hit that button, it brings up this dialog. So with this dialog, what we can do is we can actually alter these times and separate individual time windows out. So if we did have that impurity in the middle and you wanted to collect it, we could actually select that as an additional tube for collection. As of right now, we're just going to pick the peaks 1 and 3. In this case, it's really the first and second enantiomer, the left and right enantiomer. The cycle time, as you can see, is adjustable. So we can actually change that out if you want to make sure that we have a little bit of wiggle room on each side of your collection, so you don't go and lose something off the back side of a stack into the next injection. So it'll automatically determine the cycle time and the windows based on the peak collection. So as it defines the peaks, that's how we are actually determining the cycle time. Like I said, we can change it if we need to, but it will do it automatically for you. Then it will automatically simulate 3 stacked injections, as you can see here. This is a simulation, not a real live 3 stacked injection, so that we can actually see how this is going to play out in real time. With this, then we can adjust some of the numbers, whether it be the number of injections, the cycle time, the entire runtime, and then we can also adjust our peak windows, as you can see on the right-hand side of the screen. And we enter the sample information right there in the center. So if you have a total of 4 mils of sample and we want to run 8 injections, it'll do a 0.5 ml injection per sample. And that's pretty much it. It'll go ahead and run the samples for you. This is what that would look like. So what we're looking at is 3-minute single run that I showed you initially. We've stacked this up, and now it's utilizing the instrument for the full span of the entire run. So within 10 minutes, we can basically increase our throughput We're going from basically 21 minutes down to 10 minutes by being able to do this. So we're increasing at least double the throughput of the system. More compound on the column is obviously going to be more compound to get back off. So if we can stack these injections, it'll definitely help you with your throughput and with your time of process. Next, we're going to go into a little bit of achiral with the open access instrument. And again, Josh and the marketing team did a great job of getting us some really nice photographs of the instruments as they sit, one with and one without the enclosure. The GLS you can see there, and the fraction collector valve up on the top of the instrument, which is going then over to the fraction collector itself. So we have the 2x2 on the left and we have the 4x2 on the right, which are two options. And then, like I said, the enclosure is an additional option for benchtop systems that you don't necessarily want to have to put into a hood. Now we have a little bit of a video that's going to run for you that just shows you the injection process from the right-hand side. You can see on the auto sampler as it's moving forward. It allows for us to do unintended continuous operation, multiple sample processing, or we can do repetitive injections directly out of the same bottle. We can pull then those fractions into the same vessels if you like. So as you can see on the left-hand side, we have larger bottles, or we can go into the fraction collector tubes on the right-hand side if we were doing sort of like an achiral or non-chiral separation of maybe 10, 11 different samples. Right now we're showing, I think they're 20 ml scintillation vials and the larger bottles for doing sample introduction. We can also inject out of the traditional 13 millimeter tubes as well. We have a 5 ml sample loop for the modifier stream injection. Why is this important? Because it allows us to increase our resolution. The samples are being introduced at the same temperature as what the columns are. And this goes back to the stacked injection idea as well, because we want to make sure that we have the samples being introduced uniformly throughout the entire run. We have an automated wash operation so that you can reduce the amount of carryover if we do want to go from one sample to the next and not have to worry about just sticking with one sample and then cleaning the instrument on its own. Next, we have another video introducing the open bed fraction collection. So as you can see with the instrument, it's a patented RFID recognition for the fraction collector racks. So you don't have to worry about which racks you're actually dumping into. It will automatically know. It'll line it up and it'll actually get the volume set it up just for that individual rack. So you don't have to worry about forgetting which rack you put on there. You don't have to worry about setting the volumes. The instrument will actually calculate just the amount of methanol that's coming out of the instrument as opposed to, or other solvent, I guess I should say. But whatever your co-solvent is, it will measure that and we will collect based on that volume alone, so that we get consistent across the board fraction collection. The traditional tubes that typically most people will be using will be 16, 18, and 25 millimeter tubes. But as you can see, we also have the 480 ml bottle here on the left-hand side. And it's easy to swap the racks in and out just by pulling them and replacing them with another. So they're interchangeable, readily available. Peak track also visually maps your peaks as they come off the sample, off the column. So we can actually match the sample up with the tube location where the sample actually ended up. The pictorial representation will show up here in a second. So we can do multiple samples with ease. This is our sample queue screen, if you will. So what we can do is we can actually set samples to run in sequence, one after the other, whether it's chiral or achiral, it doesn't really matter. We can choose the column and put in all the pertinent information, whether it's the amount of sample, how many runs you want to run, and then the system will calculate out how much each individual injection is going to be. We can also do things down at the bottom, which is very similar to anything that you would have seen with our ACCUPrep systems already, our traditional ACCUPrep reverse phase systems. The fraction overlay is there. The pausing after a run is there. And so is the bracketed sample. And we can get into that a little bit later with other webinars that we have out there. We go into what the bracketed sample is. It's a very easy to use queue. We can use multiple methods. The sample name can actually be changed from line to line and will come in as default. The methods are selectable by a dropdown, so it makes it a lot easier for you to be able to do run-to-run queuing. Ooh, almost forgot one thing. So the other thing that I forgot to mention, down on the bottom, we also have an export and import function. So what we can actually do is export this out. You can actually generate a sample list externally from the instrument and then draw it back in if you do have a large batch of samples that you want to process. So now on to detection. So first off, we're going to start with the default PDA detector that comes with the system. It's standard. It is a variable wavelength. We have can use 2 different wavelengths. We can do UV or UV vis range. And we can actually get a real-time plot, as you can see down here on the bottom, of the actual UV spectrum of the individual compounds coming off. Why is this important? I like to say that this is my telltale as to whether or not a compound that's coming off is an enantiomer or if it's an impurity. So this will actually give us a pretty good idea of whether or not the 2 individual enantiomers, or at least what we think are enantiomers, are really enantiomers, because we can match up the spectral information. If it is not an enantiomer, obviously you're going to see a different profile, whereas the peaks may look identical at one particular wavelength, but you may not necessarily have the same compound. So this will give us the ability to make sure that that is in fact the other enantiomer. We can collect peaks based on UV, threshold, or slope, purity measure, and even also do a wavelength range where we do a large span of the wavelength. Traditionally, most people will use just a simple UV threshold or slope parameter, which is pretty robust, as you could see from the fraction collection parameters that we used for the stacked ejections. I mentioned earlier that you can have a nice pictorial representation on the left-hand side here of where the actual vessel or the tubes are going into. So as you click onto each one of those fractions, it will actually show where it came up in the display or in the rotary of the valve. So all these are getting stacked into the same vessel. The color differentiation is strictly due to the fact that it's multiple injections. And at that point, I think I'm going to transition this back over to Josh. Thanks for having me along for the ride today, Josh. And looking forward to hear what we have coming up here in the near future.
Thanks, Todd. It was a really good walkthrough of the features of the ACCUPrep SFC in both chiral purifications and achiral work, and how you can use the system with and without the auto sampler there. So to summarize kind of what we wanted to take home today with regarding the ACCUPrep SFC is some of the highlights there is to do more in less space. So there's several different compact options to fit your space and needs. You can, focus a system on chiral or achiral purifications, bulk purification or multi-sample purification, or you can do both and just easily swap between the auto sampler. Additionally, it's a powerful, versatile system. So it's engineered for consistency from injection to injection. It's a robust CO2 pump paired with an advanced mass flow controller, an automated back pressure regulator for accurate flow control. And ultimately, stability is important in reproducible chromatography. And that's, really at the heart of the system, in addition to the standard options like the oven drawer and thermostated oven drawer and the other standard options on the system. You can expand the range of SFC purifications to include more polar compounds and run up to 70% co-solvent with no limitations. And really the unique technology and design. So, one is the patented GLS is at the core of the system on the fraction collection side, as it offers reliable use, minimizes downtime, and opens up the full capability of Prep SFC without sacrificing sample recovery and other method parameters like limitations and flow rate. And I think design is really, ties into the space component of this. You don't need a PC, the footprint, and how much engineers have been really able to optimize the design of the system and get a lot of bang for your buck in a small space there. And then finally, at the heart of all of our Teledyne ISCO chromatography options is our software interface. And the PeakTrack software is intuitive. It expands Prep SFC to more chemists with reliable operation, and offers a really quick learning curve. Essentially, if you were to spend less, 5 minutes at the system, you'd be have a pretty good understanding of how to start a run and be able to get going and have a successful purification. And ultimately, this allows us to increase our throughput and lab efficiency with quick method and stacked protocol developments. Feel free to follow us on social media, on Facebook, Twitter, LinkedIn, and YouTube, following handles. And at this time, we'd like to open this up to any questions. You can all use the QA feature in Zoom, but you can also email either Todd or I at our email addresses there on the slide. Okay, with that, we'll open it up to questions here. Feel free to enter any questions in the Q&A function in Zoom. We have a couple that we'll start with, but if you guys have any others that come up, more than happy to answer those in the next 15 to 20 minutes here. So Todd here, we got a question here asking if the CO2 pump heads are chilled.
I guess I need to unmute myself now. I apologize again for not being muted when I logged into my laptop. Josh and I are actually together today, so we were using his computer and then I switched over to mine to go ahead and take the Q&As. So anyhow, yes, the heads are chilled. We use a chiller of your own choosing to go ahead and set the temperature and keep the heads chilled with the circulation bath. We also do the chilling of the CO2 line that goes into the heads as well. So you're going to basically have them both chilled to a reasonable level.
Perfect. Okay, we got some coming in now. Let's see here. Can you do stacked injections using the multi-sampler or just the collection bottles using the fractionation valve, I suppose, is what they're describing there?
Sure. So with the system that we have, we decided that we wanted to go for a system that was all-inclusive. So you don't have to just use one or the other. If you choose to use the fractionation valve and just do stacked injections, that's the standard unit. And you can go ahead and run that just with the basic system to do stacked chiral injections. If you want to do a chiral or use the open bed fraction collection, you can take the exact same system and all you have to do is just add on the software or the auto sampler, and the software will automatically recognize the collector, and you can go ahead and do regular injections as well. So you don't have to worry about buying two totally separate systems. They're both interchangeable.
Great. Let's see, couple more questions here. Can you adjust the collection number or number of injections and other parameters on the fly? Are they set until the next run? And that's, I'll just kind of take that one. But one of the great things about PeakTrack software is that you're able to make changes on the fly as your chromatography may change a little bit, especially over a long run like a stacked injection protocol where you may be doing that over several hours. So you can tweak those values on the fly within the method. You don't have to wait for the next run or resume the next run for that. So it's meant to be easy to do. Now, if you're doing a stacked injection, it's not going to let you start changing the isocratic percent or anything like that, but you can change the time windows and the cycle time. You could change the injection volume as needed to compensate for things. So let's see here. Just going through the list. Can the modifier gradient be changed on the fly as with the ISCO and ACCUPrep instruments? And that goes along with what we were saying. If you're doing a traditional gradient run, you can go ahead and insert isocratic holds, change your gradient slopes, things like that. If you're doing the stacked injections, you're not able to change those kind of method parameters. Also, you can change your time, change your detection parameters as needed during the run through the method editor and those other variables that you can set up. So nothing's really limiting you there. see, question, I guess, here is it just UV collection, or can you be paired with MS or ELSD? They mentioned that they are a ACCUPrep user and they use the pure ion. So thank you for being a devoted user there. So Todd, you want to take that answer?
I'm sorry, I was typing the one question next to it. So go ahead. What was the question again?
So, is a system limited to UV collection, or is this, you can compare this with other detectors, MS or ELSD?
Correct. So we are actually going to have this running both ELSD and MS. We don't have them in the original releases of the unit, but they are being worked on for future releases. Once we get the instrument launched and finally getting some feedback from customers, make sure that the base instrument is working as it should be, then we'll implement other detectors and other functionality as well, just like we have done with the ACCUPrep in the past.
Okay, great. Another question regarding the size of bottles you can collect into. With the fractionation valve, Todd, I think you're not limited really at all in the size of your...
There's no limitation to the fraction collections. You can basically have it going off to 50-liter vessels. That's the original systems I used to use, was running normal phase systems where we had like big 50-liter containers. We can do anything from small bottles up to 4-liter bottles. I think that would probably be about as large as you want to go, though, for just functional purposes. But since we do have tubing, we can pretty much go to whichever valve switcher you want and collect unlimited amounts.
Another question here. Let's see. In the stacked injection mode, will the system track the volume being delivered to each collection bottle over all the subsequent injections?
Are you ready for me to answer it?
Yeah, if you want to take it, or I can take it if you want.
You can take it.
Okay. Yeah, and so Peak Track is going to be monitoring the liquid volume into your tubes. So it knows you'll input basically the size of your container for the fractionation valve if you're using it, or if you're using the bottle rack on the system, it knows the size of the bottle on the system. And so it's going to track the liquid volume going into that container, and then it's going to have a set point based upon when you would start to get not necessarily overfilling in this case, but because of some of the CO2 being released, splatter. So there's a set point there for that. So it is being kept track in the system actively, and it adjusts based on your percent co-solvent that you're using, because that's going to affect the volume of each peak. Another question here is how, I guess, can you use this in oligonucleotide purification? Todd, do you have any application examples with any of maybe your users that have used Prep SFC, and maybe what are some drawbacks that to using that application, or limitations?
Yeah, sure. So traditionally, oligos, from my experience, have mostly been sort of an aqueous-based purification system where you needed more of a polar media to carry the compounds through. So with CO2 SFC, you typically would not look at using normal phase to purify oligos. But in the instance of SFC, we're trying to figure out how we're going to do that. Up till now, me and a couple of the colleagues I was just talking with, and old friends, water used to be a very big no-no to put into SFC systems. Now we're starting to see some people using some different solvents, blending solvents, for instance, using a little bit of water in with the methanol. So we're seeing a lot of different things. So until we actually get a chance to work on a system with someone who is doing oligos, I wouldn't say it's out of the question, but the drawback is definitely going to be solubility and getting a proper chromatography parameter for those oligos. Based on the SFC.
Yeah, I would agree. There's just going through the literature, there's some examples, but there's not as many as in different other application areas. And I think as Prep SFC becomes more prevalent, that will be explored more, and to see if there's possibilities there with partners with the systems that we have. So it's
Absolutely.
something we want to investigate. So good question here regarding using bottle racks on the fraction collector. So if you're using bottle racks and you continually empty the bottle for dry down during the run, will the system recognize that? Or is there a way to let the system know? To answer that question, so it's not going to know you're emptying in an individual bottle. If you do have a 4x2 system, when you pull that rack out that you're not using, you could go ahead and replace that, and it's going to ask you if your rack is empty, if you want to start at the beginning or start where you left off. So that would kind of be the way you would handle that currently in the system. It does bring up a good question, though, that and maybe for future software development is a way to let the system know that you replaced a larger volume fraction like that during the run. So that's something that we can kind of note as a possibility in the future for that. Let's see. Just going back between the screens here. Make sure we got all the ones in the comments section.
I'll keep an eye on the chat.
Okay. And then let me see here. Answered that one. You got a question regarding the network capabilities of the system, Todd. You want to handle that?
So we're basically architecture very similar to what we're already using with the ACCUPrep. So with the ACCUPrep, we can do networking through your traditional Ethernet network, or we can also do printing to a PDF drive that you can actually, a thumb drive that you can actually drop PDFs onto after each run on the front of the system. The other option is you can directly connect a computer to the instrument if you needed to do data manipulation, where we can actually take and export the text file with all the raw data onto the computer or network and manipulate it there with a secondary software that we use to re-render the chromatogram after the fact. So there's plenty of options.
Okay, and that answered that question also. Are you seeing any other questions, Todd? I'm not seeing any others.
I don't see any. Not over here on the chat anyhow.
Perfect. Okay. Like I said, first, thank you guys for your time and joining us today. Feel free to reach out directly to myself or Todd. Our email addresses are below there, todd.anderson@teledyne.com or joshua.lovell@teledyne.com. Want to say thanks to Todd for joining us today and sharing his expertise and knowledge with us and in the development of this and sharing it with you guys today. And look forward to you guys joining us in future webinars. So thanks, Todd.
Thanks, Josh. Thank you all for joining us.